so video on the first derivative test, which will talk about where functions are increasing and decreasing, and then how we can talk about relative extrema using that information. All right, so derivatives are, it's kind of like anytime somebody says tangent line, you say to yourself derivative. So as soon as somebody says, I need you to find a relative max or min, your mind is going to say, find the derivatives, okay? Because the derivative can tell us where a function is increasing and decreasing, and a relative max or min occurs where it's increasing to do changes from one to the other, increasing to decreasing or vice versa. Okay, so on this exploration that we're going to have, you might need to pause the video if you don't have your stuff with you, but you're going to use some colored pencils here to fill this in. So get your bag of stuff out where you've got colored pencils in there, and we're going to answer some questions here using different colors so that we kind of color code that. So the first thing that it asks us to do, so again, just pause that if you need to go get whatever you need. First thing it says, use red, and it says circle all the points corresponding to a local maxima of f, not including any endpoints. Okay, so we're going to go back to the graph, and we're going to look for local maxima. So peaks or valleys. So right here is a local maxima, and right here is a local maxima. So on that, or relative, either word, so that's a peak. Those are high points where the function changes from increasing to decreasing. So it asks us on our paper to then state where those x values, state the x values where they occurred. So again, sometimes this will be what your AP test says, and if you look at the graph, you can see why, because they didn't give you the y values, right? So they have to just ask you where did it occur. So be careful though that when you answer max and mins, it's the y value unless they say answer the x where it occurs. At each maximum value, f changes from increasing to decreasing. Okay, that's very important. The function changes from increasing to decreasing there. At every maximum value, f prime changes from positive to negative because the function is changing, it's increasing and then decreasing. And so, of course, where the function is increasing, f prime is positive. So all of those things are very important, okay? So now we're going to go to the next page where it says use blue now. So get your blue, a blue colored pencil, and we're going to circle all the local minima, okay? So we're back to our picture, and we're going to circle where we have a local minima. So here is a minimum, and that's it. There's not another local minimum. So, and it's going to ask me to answer where it occurs and then what f and f prime do. Okay, so you can see that the function changes from decreasing to increasing right at that place. Okay, so the x value where the minimum occurs was at x equals c, and the f changes from decreasing to increasing. And a lot of times when I'm looking at these and I don't have a graph, I just sort of draw in the air, decreasing to increasing. I think about, oh, that's a minimum. Okay, at each minimum value, f prime then has to change from negative to positive, since a negative f prime means decreasing for the function f, and so on. Now, number 3, each local extrema value for f prime, we notice that the derivative is either 0, like at A and at C, or like at D, the derivative is undefined. So that's what has to happen. The derivative is either 0 or undefined. And so that's how that's going to give me those critical points that are the only possibility for where the function can have a local or relative max or min. All right, next part says use a green colored pencil and sketch a tangent line, if possible, at certain points and talk about the sign. So now we're going to go to point B, and we're going to try to draw a tangent line there. We're going to draw one at B, D, and E if possible. So we go back to our graph. At B, if we want to draw a tangent line, you guys have protractors, so grab your protractor and draw this tangent line. Well, it's kind of sneaky because the tangent line is going to have to kind of go on both sides of the graph here, because we don't have a way to make it not do that at that particular place, and that's kind of important. Then we're supposed to try to draw it at D, but at D we can't draw a tangent line, right? Because we got a cusp there, so there's no derivative. And then at E we have this nice horizontal tangent line. Okay, so there are the tangent lines that we were able to draw. So at F prime, or at B, F prime of B was negative. So looking at your graph, flip over and look at your tangent line, and you'll see that this FB prime is negative. And then the question is, what is the graph doing right there? Well, right there, and I'm going to kind of erase the tangent line because it's kind of big. Notice that right here at that point, that graph is changing concavity. It's changing from concave down, and right at that point then it switches to being concave up. Okay, so it switches concavity there. That's an important concept that we'll get to in a little bit. But basically we want to notice that it goes from concave down to concave up at x equals b. At that point it goes from concave down to concave up. At f prime of d, that's where it was undefined, right? We couldn't find a tangent line there. And then it says describe the change in the behavior of the graph at this value. And then we're also going to answer this last one. So let me fill in what it was 0. This was the one that was 0. Now let's look at the behavior of the graph at both of those places. So if we look at D, we see that at D, all we can say is it goes from increasing to decreasing there. So it did give me my relative extrema point. It just doesn't have a tangent line. And then again, when we look at the point at E, which I'm just going to erase the tangent line again so you can see. So right at this point, it goes from concave up to concave down. Okay, right at that point. So that's another change that will be important here. Oh, so at D, F just goes from increasing to decreasing. So since it went from increasing to decreasing, and it was undefined there, but we still know it's a relative max. And at E, the slope was 0, and it changed from concave up to concave down. Okay, and in a little bit we'll put all of this stuff together to kind of get the idea. Now, of these 3 points, which 2 points are points of inflection? So points of inflection mean where the concavity changes. So that was x equal b and x equals e, and that's because concavity changes there. Okay, it did not change. We did not have a concavity change. If you look back at point B, it was concave up on both sides. So we did not have a concavity change there, so it is not a point of inflection. So that's some terms that we're getting to. We'll define them really a lot better here soon. If a function has a relative extremum at a point, then the derivative at these points is either 0 or undefined. Is the converse of this statement true? So the converse would be if the derivative is 0 or undefined, then you have a relative extreme point. Okay? Well, it's not necessarily true. Okay? No. Because if we look back, we can see that we did something at B, D, and E. If we look at E, we did have a derivative that was 0, because remember the tangent line there is 0, but we do not have a relative max or min. We don't have a peak or valley there. So having 0 or undefined may or may not give me a relative extrema. But it is true, if it's a relative extremum point, then the derivative is either 0 or undefined. Okay, that's true, but the converse is not necessarily. And that point justifies my answer is that x equals E. And that's because f prime of x equals 0, but the point at E at x equals E is not an extrema of f, okay? So it is not an extreme value, okay? So really important to remember that. If you have a relative max or min, the derivative must be 0 or undefined. If the derivative is 0 or undefined, it might be a relative extrema, but that is why it does give me the place to check, okay? Now let's talk about increasing and decreasing, and then we'll talk about relative max and mins and stuff in the first derivative test, and we may end up doing some of that in class. Let's talk about increasing, decreasing first. So that was kind of a summary of all the things that we sort of know here. All right, so a function is increasing. These are definitions that you had from pre-calculus. A function is increasing on an interval if for any x1 and x2, if x1 is less than x2, then it means that f of x1 is also less than f of x2. In other words, if the x value is to the left of another one, then the y value is below the other one, okay? And then decreasing would be the opposite. Same thing's true, but here if the x is to the right, so you have a bigger x to the right, then its function value would be above the other function value, okay? That's the formal definition. We're going to look at it by answering it with, calculus stuff, looking at different things. Okay, so looking at this graph, we have a graph from -3 to 7, and we want to talk about where this function is increasing, decreasing, or constant. And we're going to do open intervals because we have to be cautious about the endpoints of an interval, okay? So we're not going to get into why you include or don't include them. You can always do open intervals, and they're not going to count off on the AP test, so we're not going to get into a big deal about it, okay? So we're going to answer increasing, decreasing intervals on open intervals, okay? So f of x is increasing. Well, it is increasing clearly from -3 to -1. We can see that it's increasing there, and it's not increasing anywhere else. F of x is decreasing. Well, it starts decreasing at 2, and it decreases to 7. And then it is constant from -1 to 2. There's our constant. And again, don't include the endpoints. We'll discuss at some point why you can include them and all of that, but it doesn't matter. AP is fine with them being not included. All right, so a function is called monotonic if its first derivative never changes signs. Okay, so you're going to have a function, in other words, it's always increasing or always decreasing. So if you ever have a function whose derivative is always positive, then we would say that that function is monotonic. Okay, so how can we figure out where it's increasing or decreasing? Well, the easy way to do that is it can only change signs. So if the derivative being positive means it's increasing and negative means it's decreasing, well, the only way for a function to change signs would be where it's 0 or undefined, okay? So if you have a graph and you have a function and it's over here negative and all of a sudden it becomes positive, well, it had to go through the x-axis for that to happen. Or there has to be an asymptote there and it jumps across and it's positive on one side, negative on the other. It can't change signs any other way. It either has to go through the x-axis or jump over it. Okay, so therefore, wherever the function is 0 or undefined is the only possible place for it to change signs. And since the sign of the derivative tells us increasing, decreasing, then that's how we're going to do that, okay? So, some important things that you need to probably highlight here, and this is how we find it. So first, you're going to find the critical values. Then you're going to make a number line, a sign chart. And then you're going to pick numbers in between to find out if it changes. Now, this note here is really important, and I would definitely highlight it. Your sign chart is not valid justification. You must write a statement communicating your mathematical language related to the sign of the derivative, and do not use pronouns. So no, it is negative or something like that. So an example would be you do a sign chart and you find out that G prime is positive from -2 to 5, so you would answer the function G, not it. The function G is increasing on the interval -2 to 5 since the derivative G prime of x is greater than 0. Okay, so I will model that very carefully. So again, practice, 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 right? We need to make sure that you are practicing what you're going to want to do when you do your tests, okay? So practice on all of your homework, doing everything the right way, so that when you take and have a test to answer a free response question, you know exactly what to do. So this says find the open intervals on which this function is increasing or decreasing, and then justify. Remember, whether it says justify or not, you're always going to justify. So first step is find the derivative. Okay, so when you take the derivative, make sure, I don't want to see anybody thinking that they should write 6/3 here. 3 times 2/3, the 3's are going to cancel. So we get 2x squared minus 2x minus 4. And then what we want to do is set this equal to 0. So while I set it equal to 0, I'm going to factor out the 2, because of course we want to always factor out the greatest common factor. And then either 2 is 0, which it's not, so you can ignore that, or these factors equal 0. This is all that matters, is when does this equal 0. This is a pretty simple one to do, x minus 2, x plus 1. Always multiply back your factoring. You don't have to do it physically, but right while I'm talking right now, I'm foiling that to make sure I catch any sign mistakes. And so my answers are 2 and -1. So then what I'm going to do is make a sign chart. This is not justification, but it sure is the way I'm going to figure out my answer in a really easy way. So this is basically a number line, okay, where I have my possible places that the function could change signs, which would be at -1 and 2. Now, I like to write above it, I'm going to write that it's 0 here and 0 there, because up here, you're going to write what f prime is doing, and then below it, you're going to write what that means for f, okay? So the sign chart, we're looking at, okay, we know that f prime is 0 at -1 and 2. We literally just found it, okay? So I put zeros up there. If it was undefined, and that's why I was using it, I would just put UND right there. So this graph cannot change from positive to negative or negative to positive unless it goes through -1 or 2. So all I have to do is pick any number in this interval over here and test it and find out if it's positive or negative, because all the numbers in that interval have to be positive or negative for f prime. So we're not plugging into f. This is for f prime, okay? So the easiest way to plug in is where you factored it, if it's a problem you factored. Because I don't care what value I get, I just care, is it positive or negative? So I'm going to pick an easy number. I can pick anything less than -1, so pick something easy like -2, okay? -2 is less than -1. If I plug negative 2 into x minus 2, that's negative 2 minus 2, that's negative. Don't write down negative 4 or try to do the arithmetic. All I care about is that's negative. Negative 2 plus 1, second factor that we have there, also negative. And it's a negative times a negative, so that means it's positive in here. Okay? So now pick any number between negative 1 and positive 2. So I'm going to pick 0. 0 is easy to check. 0 minus 2 is going to be negative. 0 plus 1 is positive. A negative times a positive is negative. So every value in there is negative. Every value of the derivative. Pick any number you want bigger than 2. So let's pick 3. 3 minus 2 is positive. 3 plus 1 is positive. Again, I'm checking right here, just checking in my factors. Positive times positive is positive. So now, as a little connector here, I'm going to write down, so what does that tell me about f? This information was f prime. So what do I know now about f? Well, what I know about f is, since the first derivative is increasing on this, or is positive on that interval, my function is increasing. Since f prime is negative on this interval, f is decreasing, and f prime is positive, this is increasing. Okay? Now let's read the question. Find the open intervals on which it's increasing or decreasing and justify. So the work that I've done gives me super easy way to answer. So basically this is the answer to the question. So that was my work. Now I need to answer and say f of x is increasing on, and I'm going to list my intervals. So it's going to be minus infinity to negative 1 union 2 to infinity, and then I have to give my reason, and my reason is because f prime of x greater than 0. Remember, that's how you say it's positive there. So I don't have to write a paragraph. It's increasing on those intervals because f prime is positive, and it is decreasing on negative 1 to 2, so in between there. And again, my reason is very simple, because f prime of x is less than 0, and that's it. I've explained it. Okay, so the questions are pretty easy to give us lots of information. So that's how we're going to do that. So this is actually called the first derivative test. Okay, so what I just did is the first derivative test. So this is a test for, sorry, not the first derivative test, but that was the test for increasing and decreasing. But remember, since the function was continuous, right, this is a polynomial, so it's continuous, then if a function changed from increasing to decreasing, then right here must be a relative max. And right here must be a relative min. So that's what's the first derivative test. So that's what's going to come up next. So we're going to do the same exact thing, but you're just going to write in what I just said and then also answer that. Okay? So if f prime of x changes negative to positive, there's a relative min. If f prime changes positive to negative, there's a relative max. If f prime does not change signs, then there's neither one. We do know that if there's no sign change, there's neither one. Okay? So this is the idea of what it looks like if you want to classify it. You kind of look at the graphs there, but I'm not going to worry about that. We're gonna start exploring different things and talk about that. Now, I prefer that you do not use these symbols necessarily. Your sign chart doesn't get checked. So if you use these symbols, it will be fine, but you may not use them when you're writing your explanation, if that makes sense. So what this is saying is if I have this shape, it's concave up. If f is concave up, then we know that the first derivative is, or second derivative is going to end up being positive. So we actually don't know that f prime is increasing. But if f prime is increasing, the first derivative is positive. This is kind of a, I would say, let's don't, no, this is true. F prime is increasing, sorry, because its derivative, second derivative, is positive. If it's concave down, f prime is decreasing because so its derivative is negative. But we'll get into that later on the concavity. So right now, just focus on local extrema, increasing, decreasing. So let's do this last example, and then we'll do more stuff in examples in class. This is a really important topic, so we want to really get this down. All right, so A says find the open intervals on which f is increasing or decreasing, and then justify them. And then we also want to do local extrema. So like I said, I'm going to write everything in one sign chart, and then we'll just write everything out. Because remember, your work is for you, so this is kind of your showing that you're doing your work and the sign chart, but that's not the way to answer. The answer has to say, these things happen and this is why, okay? So the sign chart and stuff are not justifications. They're just work that's there showing that you did do the work. So that is important. You have to have work shown, but it's not the justification. All right, so anytime something says find out where it's increasing, decreasing, local extrema, relative extrema, absolute extrema, find the derivative, okay? Tangent lines, find the derivative. All those things tell me, first thing I need to do, find the derivative. Now, because it's asking for increasing, decreasing, and relative extrema, then that means I want to know when does this thing equal 0. So I'm going to go ahead and set it equal to 0 as I factor out what we have in common. So you're going to factor out a 4x as we set it equal to 0. And then further, this is going to be 4x times x plus 2, x minus 2. I kind of prefer you go ahead and factor it because most common mistake here is if you go from this step, you might not get -2 and 2. So be cautious. If you factor it, you won't miss those values. So then what I do is I just go over here and I make a sign chart. So this time I have -2, 0, and 2. All of these places, f prime is 0 there. And let me switch colors just to make it a little bit easier to see the work. So there's my sign chart, and I recognize, hey, f prime on those intervals at -2, 0, and 2 was 0. That's what I literally just did. So again, the only place that f can change from positive to negative, or a function, sorry, f prime, is if it goes through 0. Or it's undefined, but I have no undefined here, okay? So I pick any number to the left or less than -2. So I'm going to pick -3. Okay, again, easiest to check where you have it factored. Now you could check it in either this one or this one. It doesn't actually matter. Either one of them is going to be easy to check. So I'm actually going to use, and I'm just going to write it right here because you're not physically watching me do this on the board. So you can't see me. So I'm going to show you what I do. Is I'm looking at 4x times x squared minus 4. And I'm going to pick a number less than -2, like -3. If I plug -3 into 4x, I get negative. If I plug -3 into this expression for x squared, I'm going to get 9. 9 minus 4 is positive. So I have negative times positive, which means everybody over there is negative. Now continue to do that. So I'm going to pick -1 next. So if I plug in -1, I get negative. -1 squared is 1. 1 minus 4, also negative. So this is going to be positive. I pick +1. 4 times +1 is definitely positive, but 1 minus 4, still negative. So this is negative. Pick a number bigger than 2. 4 times 2 is positive. So pick 3. 3 squared is 9. Minus 4, I get positive. Now, These two examples, it alternated. That is not always the case, so be really careful that you don't just say, oh, it started negative, so it's just going to alternate, because that's not true. Okay, so now let's answer what we know about f. That was f prime. This is what f prime is doing. So if f prime is negative, that means f is decreasing. If it's positive, f is increasing. Negative, decreasing, positive, increasing. Then in between, so at -2, 0, and 2, we have relative max and mins. So at -2, it changes from decreasing to increasing. So that makes this a relative min. At 0, f changes from increasing to decreasing. So this is a relative max. And at 2, we go again from decreasing to increasing. So this is a relative min. Just think to yourself, decreasing to increasing. So I'm going to have a relative min. Okay? So now let's answer the question. So it's really pretty easy. I got all my information, and now I just need to give the answer. So it wanted decreasing, increasing, and so on. So, and relative extrema. So I'm going to answer f of x increases or f of x is increasing on, so I look at my chart up here, so this is what tells me that information. So it's increasing on -2 to 0, union 2 to infinity, and then again I have to give my reason, and I simply say because f prime of x greater than 0 and decreasing on, so I just answer where I put DEC, so minus infinity to -2, union 0 to 2, and again my reason is because f prime of x is less than 0, and then it wants me to answer my max and mins. Now here's where I have to be careful, because I have to be sure that I answer what it asked. This did not ask me for the y value. It said determine the x values of any local extrema. That helps me out tremendously, because plugging these numbers into this original equation wouldn't be too fun. Not too bad, but sometimes it's really messy. Okay, so luckily it just said at. So be cautious though how you answer the question. You would say a relative max occurs at x equals, and we look back to our chart, relative max was only at 0, at x equals 0, and our reason is because f prime of x changes from negative to positive here. Okay? Now you could also say f changes from increasing to decreasing, because we've already listed that. But I would get in the habit of answering it from f prime. And then there is a relative min. Relative min occurs at x equals -2 and x equals 2. And that's because f prime of x changes from negative, no, not negative to positive, these are relative. Oh yeah, so the other one was, sorry, the first one up here, this was the relative max, I'm sorry. So the relative max occurs because it changes from positive to negative. So be sure you get that switch. So hit pause and fix it. And then the relative mins is where it goes from negative to positive. Okay, here. So at those places, okay, because that's where it occurred. So if it did not say that, it didn't say the x values, we would have to plug them in and find out the y value. All right, so that's all we're going to do on this video, and we'll do the rest of the notes in class. So just make sure you go back over that and really look through it so that when we finish in class, it'll really be clear.